a warm welcome to our speakers and welcome to the Congress to everybody. Our speakers are Stephanie and Patricia. Hello, and applause by you to welcome them. Thank you. Maybe you expect a Moritz, because there was a Moritz in the program scheduled until like some minutes ago. After refreshing the program plan, there is Stephanie. So that's why there is no Moritz and there will not show up a Moritz. It's Stephanie and there was an error. So sorry for that. They will talk about like hacking and doing yourself stuff. It's about ethical hardware. They told me the title is Clay PCB. We built an ethical hardware kit with a PCB microcontroller. And there's also this feminist hardware, which they will be talking about. So I'm very excited. And the stage is yours.
Thank you.
Thanks.
Thank you. Wow, big audience. Thank you so much for coming. We are super excited to be here presenting our project Clay PCB. It's actually in exhibition in the ground floor on the Art and Play area. So I invite you already all to come. I'm Patricia Reis, Stephanie Buschitz.
Yeah, we are so honored to be presenting to this community. We are trying to use feminist hacking in order to build something that lives up to our standards, what ethical hardware could look like. And we would like to tell you a little bit about how we got started. We met in a fab lab, a feminist hack lab called Miss Balthasar's Laboratory.
Which was actually started by Stephanie Buschitz in 2011. And basically we've been working together since 10 years, I guess, or a little bit more. And in this community space, which is also like, let's say, a space for makers and feminist hackers, which are working on the intersection between art, science, and technology in Vienna. And we are very proud to say that we are part of a broad network of trans-feminist hacking peers around the planet. And in our community, we are very much committed to the feminist hacking and especially methodologies, also to demystify, later to decolonize technology, with an emphasis on workshops, peer-to-peer learning, exhibitions, and of course other events that have this goal of empowering marginalized groups, including cisgender and transgender women and non-binary individuals. So this practice do not only sought to challenge the underrepresentation of flinter individuals, so it is, again, intersections so between art, science, and technology. We came actually all into the field of technology through art, and but also we aim to mitigate this gender bias in the maker community, so through collaborative, inclusive knowledge sharing processes. Yeah, so we do many different workshops. Usually our workshops are only for female, non-binary people, and for instance, these are just some images. We don't have so much time to introduce you to the space, but I would like just to give you some images of the workshops. We have this, for instance, from Jana Fremer-Moser. She will be also talking here tomorrow, I think. And also exhibitions, and we try also to focus on exhibitions in the form of a solo show. So the idea was that in our community, most of our peers were artists, also struggling with having visibility in the art community field, and we decided to create also a stage where they could show their projects, sometimes working in progress, sometimes already towards an end of the research. We also started in Vienna a couple of years ago a female artist index, so it's kind of an online network where all these peers can somehow collaborate, exchange, and get to know each other. So this PCB project, it somehow departed from this network and this hacking somehow context, and it aims to address to urgent global challenges which are tied to mining, extraction, contamination, conflict, and exploitation. So by connecting this feminist hacking practice with also what we call speculative methodology, so actually this is a speculative also art and design project, We propose to rethink hardware production and also its use in different artistic contexts. So this clay PCB project reimagines electronic hardware production with a feminist, colonial, and ecological principles. So it acts as a little proof of concept for collaborative, care-driven work. So why hardware? We asked in our research, because there's no software with hardware. So it's sometimes, especially in our field, and with the advance of technology and with people that are less experts, we very often have sometimes this misunderstanding, or we forget that hardware or there's software and our tech comes from stuff that actually exists in the world, from materials that exist in the world and are extracted from the earth.
Yeah, so the question is, can we be free if we are not all free? And what I mean with that, or what we mean with that, is that if the devices you've got in your pocket or in your bag contain conflict minerals, conflict materials, such as tungsten, tin, kaolin, tantalum, gold, that causes massive destruction and war worldwide, can we as individuals say we empower ourselves, as feminists say we empower ourselves? And we think, no, it's not possible. It's necessary that we decolonize first our practice. So what would that mean if we become really aware of the whole circle of the stuff that we use and where it's going to? Then we have to unfortunately see that the mining, the manufacturing, and also the disposal, the e-waste, extends colonial practice in many ways. Extends colonial practice through destruction of the environment, but also later through contamination that is occupying not our land and our soil, but other people's. Specifically when it comes to lithium and gold and copper, we've seen tremendous increase of mining activities that are not democratically made in consent with the population. So that's why we're looking at not only gold and copper, but also kaolin mines, and especially in Southeast Asia, where, for example, in Papua, there are really wars going on that we never hear on the news, or Congo now. So all of this is not fun, not good. We cannot support this without making ourselves part of this guilty circle of empowering capitalists. And then when we look at e-waste, as I said before, it's anyway destroying ourselves at the same time, because soil, water, and air are obviously not minding any national borders. So when we contaminate other people's lands and indigenous people's lands, in the end we harm ourselves, even if we don't feel solidarity with them. So if we try to avoid these new forms of colonialism through extractivism and through contamination, we have to try to think differently about how we care for ourselves and how we provide for ourselves. This is just a small map of our e-waste going illegally to all these places that are already having a long history of colonial exploitation and oppression. So what does feminism have to do with it?
So feminist hardware is, of course, in our perspective and coming from this context from Ms. Balthazar, essential because it challenges and also redefines our traditional male-dominated field of technology, so focusing on inclusivity, ethics, and empowerment. So it seeks also to address to the material and structural biases which are embedded in technology design, and of course its development, and which is often overlooked or marginalized women, non-binary people, and other underrepresented groups. So by fostering what open source, transparent, and collaborative approaches with feminist hardware encourage to a more ethical way of making, and in our case, art and technology. So it also promotes social justice, and it's definitely rooted in caring, consent, and repairing. So we wanted to challenge these normalized narratives of the tech commodity chain and propose an alternative. So for that, we came up with a set of rules of feminist hardware, which we call, so it's like different, it's a kind of an algorithm manifest, and feminist hardware is without mining in harmful ways, environmentally friendly, under fair working conditions, so manufactured from locally available materials without generating e-waste, with consent, love, and care. So we wanted to ask this question: how can we do hardware and avoid mining, extraction, contamination, conflict, and exploitation?
We are artists, we come from the art world, and we got a 3 years project to dive deep into this question, what is it, how could we do it? And we found a couple of initiatives actually that were also founded here in this conference that we really look up to and were inspired by, like Verlötet, or there's a lot of recycling of existing minerals like wolfram, tungsten, or gold. And there's also an attempt to use only locally sourced, small-scale farmed metal, like artisanal and small-scale mining. So there are some attempts, but it's a lot of distributed small initiatives. We of course want to mention Fair Mouse. I think it's also something founded here, and Fair Phone. So there are a lot of small groups that tried. But what is still a really big gap is a non-toxic way of recycling gold.
Yeah, so we were looking for approaches of urban mining gold, which are not the ones that are reproduced by or made with high tech, or also avoiding all these DIY videos on YouTube, how to recycle gold from your electronics with your microwave, or using some very dangerous chemicals. So we were really looking into alternatives, and we came up with porcelain, and especially, so in particular, this very old porcelain that somehow it lost in the recent decades its collectible value, and it has gold. And this gold is applied in the porcelain in a third fire, so it's a special technique. It's a paint made of gold mixed with a special oil, which is applied, and then it goes into the kiln, electrical kiln, in a special curve temperature for around 800 degrees. And this gold, of course, we cannot remove anymore we cannot recycle anymore. So we wanted to use this gold and try to include it in an electronic circuit. So how can we actually use the gold that exists already in the world, the gold that is not appreciated, or that is somehow fell into out of trend, and use it in an art installation or in the context of an interactive artwork.
Yeah, now ideological grandmoms, ecofeminists like Maria Mies, for example, who already said 40 years ago that people should more rely on each other, on shared resources and collective knowledges, and have commons and maintain commons. So we also try to rely on these very old ecofeminist principles of relying on shared maintained resources as commons, and this Kaffeekränzchen was a little inspiring for us to say, hey, there's actually gold. We've got it on our table, and we can just use that, because the ecofeminists said that either you should recycle stuff or you should use stuff that you have around where you live. So that's what we did. There's in every circuit the issue of conductive material that is necessary, non-conductive, and resistive material. So in this case, we already had resistant material in the form of kaolin, of porcelain, and conductive material in the form of gold. And some of it was becoming like a sensor, and others became like a switch on a big interface. And the interface was our Kaffeekränzchen, our coffee table. Patricia designed this circuit, and a friend of us, Erika Farina, she helped us with the embroidery, because we are not like our grandmothers good at embroidering. And then we connected it with sound samples of activists talking about their activism in other sites like Ghana and Indonesia, Cuba. And we did a performance using this interface?
Yes, and for all these projects we have developed it. There is an instruction, so full tutorial, like step by step, how to do all the aspects of, so not just the tech, but also how to do the embroidery, how to do the circuit, how to attach the controllers. And we just show you a couple of pictures of some of the performance we did. So the tablecloth is actually made for 4 participants, and with 4 different Adafruit soundboards. So they have pull-up switches, so it was easy to just connect to the conductive thread. And this tablecloth was embroidered by hand, so no machine. And yes, and here just some pictures of the performance. So we presented it many different places. The idea was to create also like this environment. We even call it Salon of Open Secrets. So the idea would be really to be grounded on this idea of like segregated sort of places where feminists can exchange ideas and grow and empower themselves. This is just a tiny video of the end of a performance. We also had transducers underneath.
It was an earthquake. It's just the question, this colonial tradition of also, of course, this bourgeois meeting of using coffee as a colonial good and sugar as a colonial good and gold as a colonial good. So the performance always ended with a shaking earthquake from a transducer under the table.
And it was also for us very important to have this, to take the time to look into the porcelain sets we found, the ones that were, some of them offered to us, or they were belonged to our families, and to really work with it, taking into consideration the agency of the materials, so not just the materials they carry from their qualities, but also their aesthetic qualities. So we tried to remove gold in the parts that we didn't want to, and add gold in the other parts that we wanted to maintain in exactly the same techniques.
So the big challenge was to now substitute the chip, because the chip in that interface, of course, was not fair trade or ethical hardware. It was Adafruit sound chip. So next we tried to solve the issue of how to make a fair trade or ethical chip. So that's how we thought about what is really already existing around us, or what is already there that we can use. And since a lot of people in the last 15 years tried and failed sometimes to learn Arduino, there are so many Arduino boards around that actually have a functioning chip on it, an Atmega chip, and it's very easy with the old ones to take it off with a screwdriver, lift it from the board, and reuse it, reprogram it.
So in a very simple way, we look into a PCB from 2 perspectives, so the conductive materials and the non-conductive materials, take into consideration that we had already this idea that the semiconductors would be somehow reused from all the electronics. So we somehow were very interested into the porcelain and did many different experiments. So these are just some pictures of how we were testing the conductivity, how we could design the circuit in the form of a tile so they could somehow connect with each other.
We only have 10 minutes left.
And also did some different prototypes of how electronically that could work. But indeed, we came up with this problem that the porcelain requires really high energy to become hard, and also the gold. So this would imply that we would have to have 3 different fires. And also porcelain is a very difficult material to work with, and we were basically wasting a lot of material just doing experiments, and we were really looking into find a more sustainable way. So urban mining the electronics, as Stephanie already mentioned, At Miss Balthazar, we had a lot of different, a big box full of Arduinos that were somehow considered malfunctioning, although the Atmega 328P was still actually working. So we decided to reuse some of these Atmegas. We had like an open call to many different places and peers to collect them, and we designed this circuit. So the circuit is, we have to pre-program the Atmega chip, and it has already some inputs, like analog sensors, capacitive sensor, like a push button, but also some outputs, could be speakers, LEDs, and even a DC motor. So it had to be just one layer circuit, so to make it easy and simple. And we came up with a 3D printed stamp, which is something that could help us to just guide, to mark the circuit into the clay. So this is how it looks like. We used urban mine silver, which was collected from leftovers, like from silversmiths, and this has to be painted by hand. And it's very important that one takes the time to paint by hand, because other modes of transferring the conductive tracks, they have a lot of waste of materials, so like stencil, for instance. So one of the most important aspects, I think, in our project was to come up with this solution of using wild clay instead of any kind of industrial clay. So with the clay, we have access and we can buy from shops. We have no access to where it comes from, where it's mined. And we were really worried about that. So we came across the work of this amazing person, Heinz Lackinger. So he's a crafter, pottery crafter from Burgenland, Stone Age expert, and who uses ancient techniques of firing clay in a bonfire. So as you can see in this picture, in his backyard, he has a hole in the ground, he uses the waste wood of his garden, and that's what he needs to fire the clay, so no electricity involved. So we had the privilege of spending a couple of days with him, for a workshop where we were walking in the woods, and he was teaching us how to collect the clay, what is clay, which soil has more clay properties than the other. So it was a very tactile journey and also sensorial journey through the forest, and we collected with our own hands, we shape it, and we use just a bonfire to fire it. So after approximately 20 minutes, the clay is somehow fired. So this is just a video, very short video from a workshop we did in Slovenia at PIF Camp this year. Yeah, so this process of firing, of course, it's also like not 100% warranty, in the sense that there is really a lot of failures. So some of the boards, as you can see, they are totally different from each other. Some are smaller, some are bigger, others crack. So it's also a lot about experience working with the material, but in particular to accept the agency of this material and work with it. So, yeah, we have, of course, in order to solder the components, we have first to bootload and program the Atmega. So we have a full list of tutorials downstairs, actually in the exhibition space. We have some QR code where we can download from the GitHub all the instructions for our project. We did an exhibition also with this project for the Ars Electronica this year, so for the Starts Prize. And
yeah, so the decolonial part is that we try not to go to the metropolis and like source everything to the center, but try to go away from the center and do something that can be done everywhere. So we made a kit that you can put like a camping kit or a picnic kit on a backpack, and it contains everything you would need for exactly this process that Pat described. You have to go somewhere to find old wood, then you can fire your own PCB and make your own input and output. A lot of people helped us to come up with interesting inputs and outputs. For example, Hannah Perner-Wilson here told us how to make our own speaker from leaves and copper and magnets. And other people also contributed with different elements that could be used as input and output that you can do wherever, in the kindergarten or in the forest. So these kits are also down in the exhibition if you want to check them out. And the whole thing is about, this is not mass production. Of course, you could never do this in mass production. It's slowing down everything. But you really focus then on who do you do this with? Is everyone in consent about it? Where did you get the stuff from? Was it existing material, or was it material that you can get from a place where it's safe for everyone? And then it's also about making it with others, of course, and learning from each other and contributing to a network of knowledge. So, should we show the video? No, right? Oh.
It is an open secret that the hardware in our smart devices contains not only plastics but also conflict materials like tin, silver and gold. We researched on alternative hardware from locally sourced materials, so-called ethical hardware, to develop and speculate upon renewable practice for the benefit of both nature and humans. To decolonize technology, we had to go beyond demystifying the black box and dive deeper into understanding the basic elements these circuits and chips are made of. This journey took us virtually to many different places around the planet, from gold mines in Indonesia to upcycle workshops in Cuba and e-waste landfills in Ghana. We aim to challenge the common PCB economies in an artistic, creative, positive and responsible way, by applying feminist hacking as an artistic methodology and critical framework. We come up with rules or standards for feminist hardware that work as a starting point to explore practice of resistance against current forms of exploitation and extraction for hardware production. Feminist hardware is developed without mining in harmful ways, environmentally friendly, under fair working conditions, manufactured from widespread available materials, without generating e-waste, with consent, love and care. We have created an ethical hardware kit within the realms of a fictitious apocalyptic future where precious resources for hardware production will no longer be available. Our kit takes the shape of a backpack, housing 3 distinct modules that fold into themselves. Each module is carefully curated to carry a diverse range of materials, tutorials and tools, emphasizing specific areas of feminist hacking. The hardware module is dedicated to hardware and PCB manufacturing with recycled and urban mined materials and tools. The wet lab module is designed for biohacking practices. The third module focuses on textile tools and materials. In the core of our hardware and PCB making module is our clay PCB. It is not made of plastic, but instead wild clay collected from the forest in Austria that was carefully prepared and modeled in the shape of a tile with an imprinted circuit and later fired with wood in a bonfire. Our conductive tracks use urban mined silver, and all components are reused from old electronic devices. The microcontroller is a tool for artistic and creative practice that can compute different inputs and outputs and is totally open source. Our PCB is built in a slow, local, decentralized and transparent way, encouraging peaceful coexistence instead of capitalist exploitation. I think we're done here.
Questions too.
Okay, we had at least more half an hour, but I think
we could talk forever about this, but I guess you have questions maybe, and we could go to the Q&A now if you want.
Thank you very much for this wonderful work and for your talk. And exactly, Punktlandung. We have time for a Q&A, and you're invited to come to the microphones, which are in the front rows, in the middle, and in the back. So we have 6 of them, and we have a signal angel for questions from the internet. And the signal angel has already a question. It does not seem so. So I check the microphones. Please wave if I did. Aha, I see. Yes, please.
Hello. Yeah, thank you for this wonderful talk. I just wonder, I mean, it's been like quite a journey. So what were like the most surprising things for you while working on this project?
For me, the most surprising thing is when we researched about extractivism, that so many areas in the world are really, really horribly affected. I think that was for me the most surprising thing, how bad it is. Do you want to say something else?
Well, that came as a surprise, but also we had a clue of it. It was so much.
I mean, it was much worse than
Yeah, I think because we both come from this more artistic field, and I study painting, for instance, so I'm very attached to the materiality of of making art. So doing things with our hands, and this was really a very important aspect. And it was, I thought I had already all the technique to actually work with clay properly, and I was surprised with the agency of this wild clay. So how it's so difficult to control. So how one has to accept, and we cannot just delete something and start from the beginning, but rather than just really having this awareness of, if this experience didn't work, now how can I take this material back to its initial form and transform it in something else that can work. So like this, it was a very important aspect of our practice, was really the time that it takes to achieve these results. So, and this is something we are always confronted whenever we go and give workshops, that people expect immediate results, and we always need a couple of days to actually play with the materials and to and not be in a hurry.
Hey, there is another question over here.
Yeah, so thank you for your talk. It was really interesting. My question is, and I completely understand that this was not in the scope of your work, but have you already tried implementing logic circuits in clay or in some ethically produced hardware? So I'm talking about like simple AND gates, for example.
I didn't catch it. What kind of circuits? Normal logical?
Like logic circuits. So as far as I understood, you just stick like a pre-produced chip on a clay circuit.
That's true. No, we didn't make from scratch a chip. But I think that it's just massive how much e-waste we've got in our drawers at home, in our desks. And it would be insane to produce something new when we can recycle. Plus, they should be built in a way that they can be recycled, which is obviously with the smaller scale now so difficult or impossible. So I think that what we need to really demand from companies is to produce in a way that it can be repaired and exchanged parts and understood and maintained for longer use.
Okay.
Yeah. And also to work with that level, we cannot work with fire. We would have to work with electrical kiln. It would be very important to be very precise on temperature and how the material, in which stage is the material. So here we are basically working with the clay just as a base for the circuit, and using the same technique has this Asian technique of applying gold, which is also in a third fire. So we basically applied the silver on the board, and then we take it to the fire for this somehow approximately, they say, 700 degrees, but it's very difficult to control. And I think that's why we were more interested to understand how far can we bring these very ancient methods of making clay before the advent of electricity, rather than just like trying to go more into advanced way to do electronics.
Are you planning to do this at some point?
Sorry?
Are you planning to do this at some point?
Well, not yet.
We could collaborate if you want.
No.
No. The next project.
Next question. The internet has no questions, so there is someone in the back over here.
Hello. You brought up the apocalypse in your presentation, and I just wondered, have you been able to recreate this project from within a single zip code or smaller local area? Because you just said the clay came from Austria. And
Sorry, it's so
yeah.
hard to understand. Could you repeat the question? I'm so sorry.
Have you recreated the project from within a single zip code or just a smaller geographic area?
Yeah, we tried to go to different places like Portugal and Slovenia, but we didn't go outside of Europe with it. But we're planning in Indonesia to give friends in Indonesia everything to do it and then do it on site in Indonesia.
So I guess my question, in Hamburg today, could you get all the ingredients you needed and recreate this project?
Here?
Yeah, using
I think
trash,
there's clay
repurposing.
everywhere in the world, yeah.
Yeah.
But if there's a place where there's no clay, you can also use wood or a coconut shell or honey bee wax. It just has to be conductive, and then you can apply the conductive thread on part.
Yeah, but maybe just a note on that, because this is really interesting. I mean, we have now a lot of practice to work with the clay that is sourced more or less from the same area. Now we got access also to a clay that was considered waste while they were expanding the U-Bahn in Vienna. So they were digging really deep, and they got this beautiful gray clay that when you fire it, it becomes red, a beautiful terracotta. So that's a completely different experience to work with. And I had a failure that I would like to share at PIF Camp this year. We found some clay, we worked with some samples, but somehow we had 80% of the results were actually cracked boards. So we could not really we would have need much more time and experience with this material from this landscape, or maybe try to find alternatives. So this is also a very slow process. I think the hardware, it's possible to find by recycling it. And the clay also, it's an experiment, but it changes from context to context, from local to local.
But for example, we talked a lot to a friend who is in Cuba, and there's really nothing that can be imported. And he also told us a lot of really amazing things that he has tried out there, where there's really lack of everything in order to still create technology. So I think it has been done, and we just have to slow down on overconsumption. Then I think it's possible.
Yeah, and even if the tutorial cannot be followed in exactly the same way, the idea, the concept can be reproduced or adapted to different contexts and local. Yeah.
There is one question, I think it will be the last because of time, over here.
Really, can I? Thank you very much. Hello, my name is Steve. And if you want, I can leave, so I keep it short. Many people have good questions, but I do appreciate your research, since I realize that women are always right. I want to thank you very much for showing this information, and I wish you the best with reaching all your goals. Sorry for talking so exhausted, I'm fucked up.
Okay, then one last question from the internet.
The internet would like to know whether piezoelectric elements used for musical instruments are problematic, and whether you know of any alternatives.
Yeah, there's another artist researching on piezo crystals, Lily, what's her name? Because the history of piezos, she found out, is actually in war weapons, and there were the 9-inch girls who were making these crystals in exact right 9-inch length, and she is researching on alternative crystals for piezos. So definitely you can create piezos that are ethical hardware. There have been a lot of people working with piezos, but we don't come from sound, so we didn't go into that. Yeah.
Okay. Thank you very much. Thank you, Stefanie and Patricia.
Yeah.